Basic Skills, Day 4. We're going to work on inequalities and graphing inequalities. So what is an inequality? An inequality is when two things are not equal, but when one is greater or less than another. So, for example, in real life, there's actually a lot of real life examples, but one example would be the speed limit. So your speed limit on a residential street, or your speed, has to be less than or equal to 30 miles per hour. Other situations, like at Valley Fair, you have to be, your height has to be greater than or equal to a certain number of inches in order for you to ride that ride. So there's a lot of examples of inequalities. So let's take a look a little bit more formally. An inequality is a statement that two quantities are not equal to each other. The quantities are compared by using one of the following signs. Now, you look at that sign. Do you know what the words are for that sign? Well, for this first example in red, A is less than B. And if we were to graph the values that are less than a certain number, we would be using an open circle on a graph. Now, compare that to the next one. Here is greater than. So A in this case is greater than B. And if we were going to graph all the numbers that were greater than a number, again, we would have an open circle, and we would going to the right because those are the values greater, where we would be going to the left for less than a certain number. The next one here is not equal to. So A is not equal to B. That's what that symbol means. I don't know if you've encountered that before, but I thought that would include it here. The next one is A is less than or equal to. So this is less than or equal to B. So if we were graphing those values on a number line, we would have the values that are less than but also equal to, so we would shade in that circle. And finally, the last one would be a greater than or equal to. So again, here are the values that are greater, and we would shade in that circle because we want to show all the values that are greater than or equal to that value. So let's talk a little bit about solution. The solution of an inequality is the value is any value, really, not just one most of the time, any value of the variable that makes the inequality true. So if I were to describe the solutions for this inequality, any value P that's less than 4, I could say 3, that's less than 4, or 3.2, that's less than 4, or -1, that's less than 4. But I can't possibly describe or list all of the solutions, so that's where I use a number line to describe the solutions. So I would have the number 4 on my number line for sure, and then to describe all the solutions, since I can't possibly list them, I would put a circle at 4. I would not shade it in because it's not equal to 4, it's only all the values that are less than. So then I would have an arrow going to the left. And that's how I describe really all the solutions. These are some solutions, but those are all the solution. So this is describing right here all of the solutions of that inequality. So if you're asked, is -2 a solution? Is 8 a solution, or 4? Okay, you could see, is that number graphed? Well, -2, yes, that is a solution. Is 8 a solution? No. Is 4 a solution? No. Because 4 is not less than 4. 4 is equal to 4, but that's not part of our solution set because we have that open circle. So that's some review and background on inequalities. So let's work on graphing them. How do we graph them? Well, again, just like I modeled, to graph, we're going to draw a circle for the number or numbers on the number line. I'm going to shade the circle if there is an equal sign with the symbol. So that means it's either less than or equal to or greater than or equal to. Then I'm going to draw an arrow to represent all the possible solutions. So again, if we make our number line here, we're going to put some tick marks or hash marks on that number line. We're going to need to make sure we include the number right here on our number line. So that means we have to make sure we have -1 on our number line, and we usually include one number that is smaller at least and one number that is larger at least. You can include more so that we know what our number line values are and what our scale is of it. So now what I'm going to do is I'm going to put a circle at -1. And you can do this actually on the number line, but some students prefer to just do it above. Okay, so it's an open circle because I do not have the equal with it. I want to graph all the numbers that are less than that, and all of the numbers less than that are going to the left. So now it's your turn. Okay, I'd like you to try to graph number 1, 2, and 3. Pause the video, graph those, make sure that you got them correct, then start the video and check your work. So for this first one, again, make sure you have -1, and the difference from what we graphed before is that our values are going to the right because we want the values larger. Okay, what's different about this next example is that our circle that we have at -2 is shaded because of the equal. And again, we want all the values that are greater than that. In our third example here, when you have your values, again, you will have a shaded circle at 6. And your arrow now will be going to the left because we want the values of x that are less than or equal to 6. Now, number 4, let's work on this one together because this is a little bit trickier. We want the values of x that are less than or equal to 3, but we also want the values of x that are, here is x, it is actually the opening is greater by x, so x is greater than or equal to -2. Or we can read this as -2 is less than or equal to x, but x is greater than or equal to 3. So here's how we do this. We want the numbers in between -2 and 3. So I'm going to make sure that both of those numbers are on my number line. And for this first part, okay, I want the values of x that are equal to 3, but also less than 3. So my arrow is going this way. And for the second part, I know that -2 is less than or equal 2x. So negative 2 could equal x, or it's going to be less than that. So that means my values of x are greater than that. And that's what my inequality solutions look like. So when you have a compound inequality, it's all the values of x in between those two numbers. Now let's work on doing the opposite skill. So can you take the graph and write an inequality for all the solutions that you see on the graph? So if we look at this, I can see right here that the number of 7 is 7. So how do all these values that I see graphed compare to 7? Well, the values of x are less than 7. Notice it's not equal because that circle is not shaded in. So your values of x are less than 7. What about, I'm going to have you try number 2 and 3 on your own, and then pause the video, and then when you're done, turn it back on to see if you've done it correctly. So for number 2, you should have x is greater than or equal to 3. And for number 3, you should have x is greater than 1 and less than 5. Now, if you didn't understand how to do number 3, I'll work through number 4 with you. Or if you did understand it, you can certainly pause the video, try number 4, and then restart the video to see. But when we look at this, we can see that x right here is equal to 4 and greater. So x is going to be greater than or equal to 4. But x is also smaller than 5, so x is less than 5. Now you could actually write this as two different statements. X is greater than or equal to 4, and x is less than 5. But we like to put that together. Oh, that is not yes, so I'm just trying to look at my values here. That's actually not a 5, that is a 9. So let's fix that. I thought that there was not the right spacing there. There we go. So you can take a compound inequality and separate it or write it as 1. And really they're both the same, but you're just going to see it written like this more often, especially when we get into graphing. So that is the end of day 4 of our basic skills.